Hi, this is Scott Whitney. This is my oral presentation for 549. And what I'm going to be discussing today is an article, paper called Implementing IPsec. And I'm going to merge that with a view into a very exciting topic for the future of this country, which is the smart grid. And many of you are aware we need to revolutionize our power distribution network in this country, and it's mandatory. If we don't do so, we will have widespread blackouts and power failures, and in order to deliver the future um, renewable and green power grid-based power grid in this country, we're going to have to use all of our technological abilities with regard to IP data communication. And a big part of that is going to be for security is going to be IPsec. And today I'm going to talk a little bit about in this presentation about some of the implications of using very computationally intensive cryptographic methods, and what we can do about the overhead required to do the decryption and encryption. So that was slide one. That was my introduction. So let's go to slide two. So the agenda, I'm going to talk about IPsec, why you should care. I'm going to talk about the paper that I'm presenting a little bit, some of their conclusions. I'm going to talk about the smart grid. Is it a perfect fit for IPsec? What are some of the challenges of using IPsec for the smart grid? What are some of the ethical and technical considerations for the smart grid? And then some future uses of IPsec, and then some conclusions. So that was slide two. Let's go to slide three. So IPsec, why is it important? Well, you like VPN, right? I mean, I do. I like to connect to the university, and be able to have a secure connection, and have an integrity of the data that I send to the university and get back. And I'd like to have confidentiality of my payload. These are all topics that we've talked about in 549. And IPsec is a good way to deliver those. I mean, there are a lot of people that do remote computing with their corporation that they work for, and a lot of that is completely based on VPN, and VPN is based on IPsec. Um, so you also like Windows Vista security features, and also IPsec is a mandatory feature of some implementations of IP version 6. So IPsec is here, it's mature, and it's going to be around for years to come. All right, so slide four. What's the paper about? Well, it's really, as it's called, it's implementing IPsec. It's the author's implementation of IPsec. And so what they did is they tried to take IPsec and move it to another level of efficiency and maturity. So what makes these authors, what did they do different? Well, they did a lot of kernel patches, and they did kernel patches for processing incoming and outgoing IP datagrams. They did kernel patches for maintaining transforms, database, and policy table, and they put some specific functions in there. So the transform and policy database, well, it's used to control what IPsec transforms are applied to outgoing packets. And so the transform database has session keys, replay counters, SPI information, such as the remote IP address that's implemented as a hash table. And the authors picks this pre-code for because it was fast and already debugged. And so yeah, they've got some details about their about what they did, and I don't know if that's really the most exciting part of this paper. I don't think that those details are what why we read the paper for this class. I think because there's a key concept that that these folks have done the research and really eloquently identified for us, and it's based on performance, and I could say it this way. I mean, cryptography, which gives us security, security comes at a cost. It's not free, and the authors have illustrated that for us. So what they did was they checked ping for latency. They used two different data pushes to manage throughput or evaluate throughput. And what they did was they evaluated throughput without IPsec, throughput and latency with IPsec, but no security, no cryptography, and then a couple different cryptography methods, and then they just measured all of these these values for performance. And if you go to slide 7, their conclusion was that encryption and encryption, decryption, cryptography hurts latency
latency and throughput,
and that the better your security or better the encryption, it's higher the cost. And so the authors also said, hey, IPsec is it's around, study it, let's continue to use it. And I think they were successful in that because today IPsec is still being used. So slide 8. So I'm going to pause here because YouTube has a small window, and we're at slide 8. Please go on to part 2. We're gonna talk a little bit about this fun stuff from this project, or this presentation, which is is all about the smart grid.